Okay, so let's build on that idea that every time a meteor strikes the ground, it irradiates the ground and the level is cumulative, and that if too many strikes occur, then that is a condition for a level fail. So we're going to do a couple of things to make that work. So let's go to GM and create a static variable, and we'll call it rad level, and it'll start off as 0. And this is going to be used for two things. One, it's going to track how many impacts have occurred. Two, it's going to be used to increase the redness of the ground. You can use whatever color you want. If you want to make it like a poison, have it turn purple, yellow, whatever, we'll just use red. Now, to make this happen, so first we created the variable. Next, we need to go to where the impact occurs. So we're on the meteor object, and this is where, okay, if it's not hitting the I-beams, if it's hitting anything else, then it should burst and be destroyed. So this is where we want to put the increase in rad level. So there's the variable we just created, plus equals 1. Alright. Now we want the object, the hills, to slowly change red. So get component, sprite renderer, color equals new color. We want it to be red, so we want to keep that 100%. The other two colors, to make it red, we need to reduce the green and we need to reduce the blue. So 1 minus gm dot rad level. I know it's messy to look at, but again, you're just saying that we want this static variable from this script. In this case, we're going to only want a fraction of it, so we'll divide it by 20, and then we'll just have the blue reduced by exactly the same amount so we don't have to tweak the equation. Okay, now this script is only attached to one of the two mounds, because if you recall, there's two of them. There's the parent here, and then there's the child. Okay, so, oops, sorry, I clicked on the wrong one. That's actually the image, so my apologies. This is the parent, this is the child, so sorry about that. So the parent has the script, child does not. So I need to make the parent aware of the child. So we're just going to do that by adding a going to do that. Make sure that error goes away. Yep. We're going to do that by adding a variable here. So we'll just call it public transform, since it's an object, and we'll just call it child mound, since it's the child object. We save that. We click on the parent object. The new variable is there. We put the child onto it. Now we can make a change to the child. So just as get component changes whatever object the script is attached to, if I preface this with a object variable, I then make that change to the object. So if we take that, put a dot, I'm now making exactly the same change to that variable. So we save it. So both of them are turning more red. I think that should do it. No error messages. Now with the impacts, it should ever so slightly turn red. Actually, did I do the increase? Yes, I did. There you go. May not be the most startling visual, but at least you can do a progression like that. And what you can do is, rather than having the default color be green, you could actually have this default be like a white. That way it doesn't go through those brown colors, that you can actually more accurately change it into red. And then we'll do one more thing. Go back here to GM. Actually, yeah, because we want the GM to overall maintain the level. So if GM dot red level is greater than 10, since we don't actually have the code in place to go to like a game over screen, for the moment we'll just put in a debug message. That way you know the functionality is indeed working. Game over. Save that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go, game over. So even though it doesn't end the game, at least you now have the ability to track when the game should end. So we actually need like a game over message and then like a title screen. But that now gives you an objective for this level, or at least one objective for the level. Now let's have the I-beams actually do damage. So what we're going to do is we're going to have to make one change. We have to turn in the hero control script for I-beams active. That variable, we are going to go ahead and make it static. I mentioned earlier that maybe we'd keep it as it was, but looks like this will be the path of least resistance. And the reason for that is that I need the I-beam object to actually be aware of this value, so it needs to be static. So let's create a new script on our I-beam. So add new script, call it beam attack. And beam attack. What we need to do is we're going to put in a trigger. So on trigger, enter 2D, collider 2D, just like we did before, and it's checking that it's colliding with another object. So if other dot name is equal, and since it's instantiated, it's actually going to be meteor with the clone suffix. So what you can do is either on the meteor script on start, you could change the name of it to just meteor, or when you're checking the collision, you can append clone to it. 6 one way, 1/2 dozen the other, whatever you feel like doing. Then destroy. Okay, so what this is saying is that when the I-beams, because the script is attached to the I-beams, if they collide with another object, destroy the other object. Now, the problem is the I-beams are on all the time, so we have to make one other check. And this is why we made the other variable static, so we can refer to it here. So now what we're saying is doesn't like that for some reason. a second one in the front here, because the entirety of all the conditions have to be surrounded by a set of parentheses, and then each individual part have to be separated by parentheses or surrounded by parentheses, and it just so happens that this object name also has parentheses in it. So, if the object is meteor and I-beams are active, then destroy it. Okay, I just jumped ahead. This has to be, so we're in the beam attack script. If other dot name is equal to meteor clone, okay, I'll put this back in here because I was trying to troubleshoot what was going on. This has to be other dot game object, so it can't just be destroy other, it's other dot game object. Save that, and then I noticed that I-beams was never being set back to no, so once you fire them, they were considered active still. So we have to set that to no when the timer runs out. And that should do it. And the whole thing needs to be parentheses. So the I-beams are out even though I'm not shooting because they're actually always there on the screen. So now I'm going to hit space. Interesting. It's not quite right. It's destroying some of them, but not others. So I think there's an issue with actually, it destroyed that one. I think I see what's going on. Is that the laser beam, the I-beam actually technically has to be out. So let's make one change. Let's make this stay. And that should take care of it. Yep, that did it. The problem was that the other command, or the other routine, on trigger enter, it's the single frame when the two colliders overlap, the single frame. If this is not yet set to Y, then this does not happen. So the enter was being detected, but this wasn't yet set to Y because the I-beams are always on the screen. You just can't see them. So when they were entering the I-beams range, the I-beams were not necessarily active, and so this was not happening. So that's that.